Assalamualaikum and greetings to all panelists and audience. My name is Muhammad Farouk Ahmad Jamil. I would like to present about subsurface geological model by using free air anomaly in Malay Basin. So for our introduction, free air anomaly, which is FAA, is the major gravity anomaly after a free air correction is applied to correct for the elevation, which in unit milligal. As you can see, this is the equation that being used to do the correction. So generally, FAA is used for offshore, which is sea and ocean area, while Bouger anomaly is used in land area and terrain. Purpose of FAA is to provide information about densities of subsurface rock. Different rock type have different range of density. Therefore, inference of about the distribution of strata can be made. Next is determine subsurface fault, which one of important application of gravity anomaly, as fault often have connect rock of differing densities. So next is FA data used in this study is satellite airborne data, which from EGM 2008 released by the National Geospatial Intelligence Agency (NGA). In Malay Basin, mohon depth is approximately range between 19 to 30 km, which stated by Madon and Ward in 1998. Next is importance of mohon depth in hydrocarbon exploration, which to determine maximum drilling depth of the well and to determine the depth of basin. Our problem statement is the latest published research on FAA was in 1998 by using European Remote Sensing Satellite, which is ERS-1. Is the latest satellite data EGM 2008 has the same features as the previous research. Are there any difference in estimating mohon depth? So next is geological setting. As you can see in the left figure, on the red spot is our study area. The study area is located at northeastern part of Peninsula Malaysia, which approximate area around 83,000 km square, 500 km long and 200 km wide, and the intra-Keratonic basin is our basin type. Then the thickness of sediment is more than 12 km of Oligocene, and post-Oligocene sediment have filled the basin, and 14 km of sediment fill. As you can see, the below figure is about the thickness of sediment that I have mentioned before. So next is our objective. We have F3. Firstly, to interpret qualitatively the study area through several enhanced maps produced by filters in Oasis Montage. Then to construct 2D contrast model of FA data from EGM 2008. And lastly, to compare the result of this study based on EGM 2008 with the previous result based on ERS-1 satellite. So next is about methodology, which firstly we determine and mark the area of investigation as A, B, C, and D on the Google Earth. As the figures A, B, C, and D is the marked area, which to produce airborne path within the area. Next is obtain FAA data from EGM 2008. After that, we convert each airborne path coordinate from GPS to UTM by using the World Coordinate Converter, which can be used in Google. Next, we import the data to Oasis Montage, and firstly we need to construct base map, then import FA data into the base map. Next, we apply low pass filter on the map to form regional anomaly with the specific cutoff wavelength. This cutoff wavelength we need to try and error until we get the map that does not change anymore. So then we apply high pass filter on regional anomaly to form residual anomaly map, which the cutoff wavelength is we use as same as the regional that we got before. So then we apply horizontal gradient filter to FAA map to form dx and dy grid. Apply formula on dx and dy grid to obtain total horizontal derivative, which the formula can be applied in the Oasis Montage on grid map. Then we construct 3D Euler deconvolution enhancement, and lastly we construct 2D GMC crash model. So for our result and discussion, firstly for free air anomaly map, the values of anomaly range from negative 39.5 milligal to 6 milligal. we show negative anomaly in overall, where it shows the presence of sedimentary basin in the upper crust. So next is result for regional anomaly map. As you can see, there are different cut-off wavelength that we use, as I mentioned before, which is 50,000 meter, 100,000 meter, 130,000 meter, 135,000 meter, and 130,000 meter. As you can see, from 135,000 meter and 130,000 meter, the map does not change. So we conclude that the wavelength that we need to be used is 135,000 meter. So for produce the residual anomaly map, we need to use the same cut-off wavelength that we got from the regional anomaly. So we use the cut-off wavelength of 125,000 meter. Next, we construct a total horizontal derivative map. This is for free air anomaly map. As you can see in the black line in the left figure, is present as a lineament. So the lineament is we compare with the previous result. There are some similarity for the lineament, which for Belumut fault, Bundy fault, and hinge line fault. Okay, next. And this also the result for total horizontal derivative for residual map. As you can see, the map is more smoother than before. So there are some similarity for the lineament, as you can see for Belumut fault, Mesa fault, Bundy fault, Dulang fault also have, Dungon fault, and also the hinge line fault. By comparing THD map and THD residual map, both maps show similarity dominant trend of anomaly reading, which in similar direction, while trending is from northwest to southwest, northwest to southeast. Sorry. Okay. Next is our result for Euler deconvolution map. This map is to show where does the source of anomaly come from, which depth does the source of anomaly come. So every color of the circle is represent the which depth does the source of anomaly came. Next. Lastly is the result of two disease class model, which estimate the basement depth and to show the subsurface structure based on the value of gravity data with average density basement rock. We use 2.76 G per cc. Seawater we use 1.03 G per cc, and lastly average sediment rock is 2.65 G per cc. The line in this figure, A to A inverse, is indicated as same the line in the maps, which straight line A and A inverse. So for our conclusion, FAA map shows the range of anomaly from the minimum value of negative 39.5 milligal to maximum value of 6 milligal. Low pass filter and high pass filter has been done on the FAA map to produce regional and residual anomaly map on cut-off wavelength of 125,000 meter. THD map detects the fault at the similar location as the geological map. By comparing the Euler map with the geological structure map, the similar fault at 2,000 to 4,000 meter and 4,000 to 600 meter, 6,000 meter were detected. And lastly, 2D gravity model shows the deepest basement depth across profile A inverse is 14 km. The difference of gravity line and basement depth compared to Mardon and Watts in 1998 is less than 5%. So thank you for your attention. That's all for me.